All right, guys. Shh, shh, shh. So today we're going to talk about polygons. So this is all about polygons, okay, and quadrilaterals. And yes, proofwriting is a part of it, so please pay attention, okay? So the I can statement for today is find the sums of the measures of the exterior angles and interior angles of polygons. All right, so this is something you have on the note sheet I gave you. It's the different names of the polygons from 3 through 12. So we have triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, and then after that, it's the number of sides dash gon. So if you have 25 sides, it's 25 dash gon. That's how you name it after 12. Yes, do they have formal names? Absolutely. I'm only requiring you to memorize those, okay? I'm sorry to hear that. Okay, anyway, moving on. Two words you're going to see within the notes is convex and concave. Convex means that it's very out, it's very open. Concave means you have a cave somewhere, okay? Usually I'm not saying all the time, but usually somewhere in this shape, you're gonna have something that's bigger than 180 degrees sometimes. Yes. Literally think of concave, think of the cave part, it caves in somewhere. Does that make sense? Convex is gonna be everything is just out, no caves, okay? Questions on this? All right, so let's take a look at example 1. So the essential question for this whole lesson is, how does the number of sides and convex polygons relate to the sums of the measures of the exterior and interior angles? So here is example 1. How does the number of sides of a convex polygon N relate to the sum of the measures of its interior angles? Here is the biggest thing you need to know about this example. When you have a polygon, if you pick a vertex and draw lines to the other vertices that are not touching, you create triangles within this polygon, okay? So if I were to do it for this side, I don't know how many there are, but if I picked one, I would connect here, here, here. It's a little thin, but it'll work. And I just create a bunch of triangles, okay? These triangles, if we find the area of them, or find the degree measure of them, or something, we're going to see it in different ways coming up. But these triangles definitely help us find the total of the interior angles of any polygon, okay? And that is done, clear the screen, by the polygon interior angle sum theorem. Now again, this is on the sheet I gave you. The sum of the measures of the interior angles of a convex n-gon is 180 times n minus 2. This is your number of triangles. So the pattern is always going to be the number of triangles minus 2 in order to find the total degree measure, okay? So for example, here they said if you're given, this is 7 sides. What's the name of that? What is it? Heptagon. This is a heptagon. All right, if I want to find that total angle measure, I take 180 times 7 minus 2, which gives me 180 times 5, and that gives me 900 total degrees. Yes, these numbers are going to be large, and that's okay, because you're literally adding in, and it doesn't have to be regular. In fact, this is what is used for non-regular polygons to find the total of those inside, of the angles inside, okay? Questions on that so far? All right, now this is the corollary to this. So the corollary to that theorem, okay, is the measure of an interior angle of and this is important, regular n-gon, so regular polygon. Regular means sides and angles are equal. They're congruent or congruent, okay? So which means all the angles are congruent, all the sides are congruent. But what we do is we still use the same formula that we would find the total interior angle measures. But then we would just divide it by the number of vertices that we have. All right, so in this case, we have 5 sides. What's a 5-sided figure called? Pentagon. Okay, so I'm going to take 180 times 5 minus 2. Okay, so that is going to be 180 times 3. Is that going to be like 720? And then I would divide that by 5 to get 108. So that means each angle measure is 108 degrees. Does that make sense? So far, so good? So the corollary is for regular polygons only. The other one, there's that top part of that, applies to any polygon. A convex polygon, I should say, not a concave one. All right, questions on that? What do you mean? Oh, did I make a mistake? Is it not 720? Whoops. 540, thank you. Thought I made a mistake. That's better. Okay. Because it's a regular polygon, which means all the angles are the same. And you would divide that to find each individual angle. Does that make sense? Any other questions? You cannot use this for anything that is non-regular because the angles are going to be all over the place. All right, they could be anything. The only parameter there is that it has to be convex. That's it. All right. All right, so try in your notebook says how many triangles are formed by drawing diagonals from a vertex in a convex octagon? All right, so how many triangles? Now remember the triangles are n minus 2. So we're on page 132 in our companion. Octagon means how many vertices? 8. So this is going to be 8 minus 2, which means we have a total of 6 triangles. Okay, so that's just like the back part of it. And that says, what is the interior angle sum for a convex octagon? All right, so we're going to take 180. Again, remember that's n minus 2, which gives us 180 times 8 minus 2, which is 180 times 6, which gives us how many? How many degrees? It's not 600. Well, 1,080. Okay, so this just says a convex octagon. Does it say anything about it being regular? No. So this is our answer. There is nothing to divide here because it is not a regular polygon. Okay? Questions on that one? All right, let's move on to the next part. Oop, I forgot I had it there. All right, so here's example 2. It says Jenna is building a cabinet to fit the corner of a rectangular room. If the 2 angles are marked x degrees must be congruent, what are their measures? So again, in this case, if we look, we have 1, 2, 3, 4, 5 sides. This is actually a pentagon, and it's a convex pentagon. But it does not say that all the angles are equal. So it's just convex. It is not regular. So in this case, what we do is we take n minus 2 times 180. That's 5 minus 2, leaving us with 3 times 8, which gives us 540. Now, if we want to find what x is equal to, we would find the missing sides by taking 540, subtracting these 3 90s, and that equals 2x. That gives us 270 divided by 2. That gives us a total of 135 for each. Now, if I wanted to check this out, I would just add up all these angles and make sure they equaled 540 degrees. Okay? So now we're going to move on to our example. What is the interior angle of a 17-gon? Oh, interior angle sum of a 17-gon. So for part A, we need to use the interior angle sum theorem. Okay? And it's going to look like that. We're going to have 180 times 17 minus 2, which is 180 times 15, which gives us 2,700 degrees. Again, letter A did not state that these are regular, so there's nothing to divide by. However, letter B is saying each angle of a regular n-gon measures 172.8. How many sides does the n-gon have? So they want you to find the number of sides given the fact that each angle is 172.8. For this, are we going to use the interior angle sum theorem, or are we going to use the corollary? Corollary, because it's regular. Who's still writing this down? I just don't want to move on too fast. I would definitely take good notes because something good is going to happen on Friday with that quiz. Just throwing that out there. Yeah, it might be a like open note or something like that.
We should do a partner quiz. That would be so fun.
Partner?
Maybe.
Maybe. We're talking about it. Okay. So if we're using the corollary, we are setting this up. 180 times n minus 2 divided by n. This is the corollary of the interior angle sum theorem. And we're setting that equal to 172.8. So the first thing I want to do is I'm going to multiply both sides by n. That helps us get rid of the fraction, okay? That leaves me with 180 times n minus 2 equals 172.8 n. From here, I distribute, leaving me with 180 n minus 360 equals 172.8 n. Now, what am I going to do after this? Who can tell me? Go ahead. Very good. So I'm going to subtract 180n from each side. Now, you're going to get two negative numbers. That's okay. So that leaves me with negative 360 equals negative 7.2n. And then I divide both sides by negative 7.2. Leaving me with n equals 50. How would I name this? What's the name of this one? Good. 50 gon. 50-gon. Not proving this. This is straight algebra today. For real. All right. Is anybody still writing this down before I clear the screen? Okay. Give you a minute.
What? I used to draw it. What?
My card is
You know what I did this in last one? I used to when he was
All right. Caught up? We okay? All right. All right. So this leads us into the polygon exterior angle sum theorem. Now, here's the thing you need to know about this. It does not matter what type of polygon you have. those exterior angles are always going to add up to 360 degrees. Etched in stone. Okay? So the sum of the measures of exterior angles of a again, it has to be convex. Concave, it doesn't work for. Of a convex polygon, one at each vertex is 360 degrees. And look right here, we have this pentagon where it's literally, they just kind of extended each exterior angle, but there's one coming off of each one. So each one of these also forms a linear pair, which is going to be helpful later on. Okay? But if we add all these up, we get 360 degrees. Now let's move on to example 3 on our book. And this is on your sheet, so you don't need to write that down. So example 3, what is the sum of the exterior angles of a convex 17-gon? Who can tell me? What is it? 360 degrees. That is it. What's it going to be for a 1500-gon? 360 degrees. What's it going to be for a 1 million gon? 360. It's not going to change. And that's only, I cannot stress this enough, it is only for exterior angles. And it does not involve interior at all. Okay? Questions on that?
No, I'm not checking.
I don't know. I thought it was a fun picture. It's actually the only one I could find that just said 360, like without having some sort of weird reference with it. All right, now take out those sheets that I gave you. We're going to work on example 4 and 5 together. I want us to do both because there's some really good differences within the problems that'll still help. Okay. So here's the first thing. It says suppose angle 1 is congruent to angle 3. So I'm going to mark that. So angle 1 is congruent with 3. The measure of angle 1 is 3x. And the measure of angle 2, right here, is x. Or 2x, sorry. All right, there's something I want you guys to be aware of because this is a common mistake that students make. Do you guys see these 2 and 3? They look really similar to same side interior angles, don't they? They do not equal 180. Do not assume that. There are no parallel lines here. Okay? It's incredible how often that happens. Don't get swindled by it. Okay? All right, so if I look at this, now the exterior angle of a polygon is 360 degrees, so we know exactly what this is going to equal. So I'm going to set this up. We've got to find x. So we're going to have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 all equals 360 degrees. Now we have some information to add, okay? So they said the measure of angle 1 is 3x, so there's that. The measure of angle 2 is 2x, so we're going to substitute that in. Now the measure of angle 3 is congruent to the measure of angle 1, so that is also 3x. And then we have the measure of angle 5 and the measure of angle 4. Both of those are going to be 90 degrees because, again, we have a linear pair here and here. So that's where the kind of the 180 is coming from. They did 90 plus 90. From here, it's combining like terms and we solve for x. Yeah, this whole box to the right. You can do it however you want. It's your paper. Please don't sweat it. I just gave you guys the extra space if you needed it. Are there any questions on where step 1 is coming from? Is anybody still copying down step 1? Okay. Step 2 is going to be to take this x and substitute it in to find each exterior angle measure. We know the total is 360, so that's a good check for us. But measure of angle 1, 3x, 3 times 22.5, that's 67.5. So I'm going to write that in. So this guy is 67.5 for angle 1. Now, in this case, angle 3 is also going to be 67.5. The measure of angle 2 is going to be 2 times 22.5, which gives us 45. So this guy right here is 45 degrees. And 4 and 5, we already know those are 90 each. So there's all our angles. That's all we need. And if we wanted to check this out, we would add it up. 90 plus 90 is 180, plus 67.5 plus 45 plus 67.5. That should equal 180 as well, giving us 360 total for the exterior angles. Questions on this? Anybody still copying it down? Okay. Now, again, this is just kind of reiterating what I just said about adding these up just to ensure you did the algebra correctly. Okay. Okay. Let's take a look at in our workbook on page 133. So this is the try it. So they're saying, suppose angle 1 is congruent to angle 3, is congruent to angle 4, is congruent to angle 6. So there's our congruency symbols right there, okay? But then they're also telling us that 2 is congruent with 5. So there's our next round of congruency symbols. And they're saying the measure of angle 3 is equal to the measure of angle 2 plus 30 degrees. And they want you to find what angle 4 is. So in this case, and these are all external angles, so we know it's going to equal 360. So I'm going to set that up for the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 equals 360 degrees. One thing that is important that I do here, though, is I got to make the measure of angle 2 equal to x, because everything is based off of that. So what this means is that the measure of angle 3 is going to equal x plus 30. But that also means that the measure of angle 1 is going to be that. And the measure of along with the measure of angle 4 and 6. While the measure of angle 2 is going to be x. And we can take all this information and substitute in. So I'm going to, so measure of angle 1, we have x plus 30. The measure of angle 2, we stated is x. So that's what we have here. The measure of angle 3, x plus 30. The measure of angle 4, x plus 30. The measure of angle 5 is equal to the measure of angle 2. So I just declared that as x. And the measure of angle 6 is going to be x plus 30. Why don't you guys take a minute and solve for this? Tell me what you get for x.
Oh yeah, I remember that. I remember that. I remember the one that was super strong. Was 240 divided by 6? I don't know. Yeah, I remember they were like Satan in the book. But you don't think there was lore behind this movie, though? We sat there for like half an hour writing down the plot and the script. I don't have mine. That was a high production.
All right, what we get for x? Who can tell me? 40. Nice job. Okay. So if we take a look, you should have had 6x plus 120 equals 360. Subtract the 120 from each side. That gives you 240. Divide by 6, you get x equals 40. Are we done, though? No. What did they ask us for? What is the measure of what? Angle 4, right? So the measure of angle 4 is going to be x, which is 40, plus the additional 30, because they told us, because remember, we said measure of angle 4 is also congruent with the measure of angle 3. And that gives us a total of 70 degrees. All right, questions on this? Whoops. What the heck? Uh-oh. Uh-oh, I forgot to put everything back. All right. All right, example 5. It says, what are the measures of the interior angles of the pentagon shown? Interior, not exterior. All right, so the first thing we need to do is mark how many sides do we have? We have 1, 2, 3, 4, 5 total sides. So this is going to be 180 times 5 minus 2, which gives us 180 times 3, which is 540 degrees. Everybody with me? All right, so this is 540 degrees. I need to solve for x. I'm going to set this up as, let me erase some stuff here, sorry. Just so I have space. I'm going to set this up as 3x plus 4 plus 7x minus 3 plus 6x plus 12 plus 90 plus 6x minus 3 equals 540. So what do we get for x? Someone tell me. What do we get? Guys, what do we get for x? 20? Okay. Is it 20? Yeah, should be, right? Yeah. All right, so now what do we do with this 20? Got to find each one, so we do what with it? Substitute it in, yeah. So 3 times 20 plus 4, 7 times 20 minus 3, 6 times 20 plus 12, and then 6 times 20 minus 3. Oops, sorry, not mean to do that. Here we go. Okay. Okay, questions on this? I'm not going to go over each individual one, but are there any questions? Okay. All right, let's move on to the final example. All right, so it says the measure of each interior angle of a regular 100 gon is 3x plus 26.4. What is the value of x? All right, guys, stick with me. We're almost done. Now, the first thing, I see regular here, and I'm automatically thinking corollary, but what's the difference here? Do I need to find that angle measure? No, they already kind of gave it to me, right? So I'm going to set this up the following way. I got to find the total of those the interior angles. So it's going to be 100 times that angle measure of 3x plus 26.4. I'm going to set that equal to how we find the total of the interior angles to begin with. That's the polygon internal angle sum theorem. Okay, so that's 180 times 100 minus 2. And from here, I solve. So I'm going to distribute here and subtract this and then distribute. So this is, or you can subtract and then multiply. It doesn't matter. Either way works. I combined like terms here. Subtracted this from each side. I get x is equal to 50. And that's it. Now the question here is this a 50 gon? No, we just solve for x. What is x doing? What is x doing? Why am I solving for x? What is that going to get me? The only reason I'm bringing this up is because there's something like this on your test. So, what is x doing? It's not giving me the number of sides or vertices. What is x? What is it telling me? Yeah, if I substitute this in, I get the angle measure back that I need for this 100 gon, right? So be careful with that. Questions? Anything? Okay, homework is on Savus. I know some of you already started it. Get going. I think it's 10 total problems. If you have questions, please let me know. Those of you watching home, have a great day.